All right, we're on worksheet number 23. This is amortized installment loan. Sometimes I'm going to refer to as amortized loan, sometimes I'm going to refer to as an installment loan. The previous worksheet, we studied different ways to save money. We did simple interest, we did compound interest. Simple interest was your principal was fixed and your interest was charged on that. Compound interest, you keep adding interest to your principals. Principal gets larger and larger. An annuity, where you put like certain amount of money each month or each week or each year or whatnot. So these are different ways to save money. In this worksheet, we'll discuss different ways to borrow money and the true cost of borrowing money. Again, we know that when you borrow money because of interest, you ended up paying more. So we'll compare like, oh, if you borrow $100, how much do I end up paying for it? So we'll talk about that. Okay, so first one is simple interest loan. In a simple interest loan, interest is calculated based on the original principal. Original principal. Okay, so even as you make payments and pay down the principal, you're still being charged interest on the original principal. So if you borrow $100, you pay $50 back. If it is simple interest loan, you're still being charged interest on the original principal, which is $100, right? So because of that, in real life, simple interest loan is very unusual. So people don't like that. When you pay back the loan, you can pay back entire amount at once, right? But more commonly, people make installment payments. Installment payments are a fixed amount of payment you make on each installment period. So let's say you borrow $100, instead of paying $100 back at once, what if you say, can I just pay you back like $10 every week? So there'll be installment payments, right? In real life, most installment payments are paid monthly. So a lot of people make monthly payments. Like I have a car payment that's monthly, I have a home payment that's monthly, so on and so forth. So those are all examples of installment payment. All right, let's look at the next part. So how do you actually calculate it? So how do you calculate the installment payment for a simple interest loan? So to calculate the installment payment for simple interest loan, we basically divide the future value, so that's how much you have to pay back, by the total number of payments, right? So if you have to pay back $100 back, and you have to do it in 10 payments, basically you're paying $10 each. 100 divided by 10 will be 10. Okay, let's look at question number 1. Just got 3-year simple interest loan. Okay, 3-year simple interest loan of $2,000. The interest rate is 4.5%. Okay, so it's a simple interest loan. She's going to borrow for 3 years, and she's original amount is $2,000. Okay, what is the future value of the loan? Meaning how much does she have to pay back? Well, it's 3 years, simple interest, $2,000. So I think I can use the future value of the simple interest, 1 plus r times t. Again, p is the principal, 2,000. R is interest rate, 0.045. Time is 3 years, t is equal to 3. So when I plug it all in, 2,000, 1 plus 0.045 times 3. When I calculate this out, I get 2270. Okay, so she borrowed $2,000 and she has to pay back $2,270. Of course, that's because of interest, right? All right, let's look at the second question. If she wants to make monthly installments, okay, what would her monthly payment be? So she has to pay $2,270, and she wants to make monthly installment payments. So basically, we have to do the 2270 divided by what total number of payments. So I have to calculate this separately. So she's making monthly payments. So in 1 year, she's going to make 12 payments. And she's going to do it for 3 years. So 12 times 3 is 36 payments. So that means she's going to have to pay back $2,270 in 36 payments. So that's each payment will be 2270 divided by 36. There'll be 63.0555 . as a final answer, I can write to the nearest 2 decimal point because it's money. So $63.06. Just to check, just check. So she's gonna make $63.06 per month times 12. So this is how much she's gonna pay a year, and she's gonna do that for 3 years, right? So this is how much she has to pay total. And when I calculate that out, I get 2270.16. So again, we said that she has to pay back 2270. When I do this, she ends up paying 2270.16 because of rounding off error. So usually it will be off by a few cents or 10 cents or 15 cents. So that's fine. So this answer makes sense. So she's gonna make easy payment, 36 easy payments of $63.00. All right. Let's. I'm gonna have you guys try number 2, and then once you're done with number 2, we'll get to the next one. All right. So after you're done with number 2, we're gonna get amortized loan. An amortized loan is more commonly used loan that utilizes a compound interest. So the issue with the simple interest loan is, as I said, if you pay back the principal, now you owe less money, but you're being still charged interest on the original amount. That's not fair, right? So for amortized loan, it utilizes compound interest. As you make installment payments, the principal goes down, because that's what happens with the compound interest. Your principal gets recalculated all the time. As the principal goes down, you get charged interest only on the recalculated principal, which is lower, right? Which is good, resulting in less interest than simple interest. So which is good. So this is more commonly used one. Your car loan, your home loan, your credit card, your student loan, these are all amortized loan. Okay. How to calculate the installment payment for amortized loan. So this one has 4 factors. So principal, this is how much you borrow in the beginning. Interest rate, obviously, compounding period is the same as installment period, K. So amortized loan utilizes a compound interest. So sometimes they'll just say compound interest, then I know automatically it's amortized loan. So there's interest rate and then there's a compounding period. Installment period, basically it's the number of installment payments per year. It's actually the same as the compounding period, right? So if you're making monthly payment, it'll be 12. If you're making annual payment, means you're making 1 payment per year, this will be 1 because that's once a year. If you're making weekly payment, this will be 52. So mostly it'll be 12, but it could be some other number. And the last one is time of the loan. So are you borrowing it for 5 years? Most car loans are 5 years. Home loans are like 15 years or 30 years. Student loan, it could be 10 years, 20 years, whatnot. So it's the time of the loan, time period. Okay, and here is the formula for the payment. Kind of crazy. So in real life, we're not gonna do this much. We'll use Google Sheet. So it's a little crazy, right? I mean, it's doable, but in practice, we'll just use Google Sheet. It makes it so much easier. So Google Sheet function for amortized loan installment payment. So basically, we'll use Google Sheet function to calculate the payment for amortized loan. For simple loan, there wasn't like a function per se. We just calculated ourselves. It wasn't too bad. For amortized loan, it's a little too crazy. So we'll use the PMT. It's the payment function. So I'll highlight that. PMT, payment function, right? So it makes sense because you're trying to find the payment. So equals, again, we start with the equal payment. We're going to input the periodic rate, total number of payments, and then loan amount. So what does that translate? So it's interest rate R. So first part is periodic rate. So interest rate R divided by the compounding period. And then total number of payments. So K times T. If it's monthly, then it'd be like 12 times how many years, right? And then loan amount P. So those are 4 factors that we talked about before. P, R, K, T. This is how you're gonna plug in. There's R, T, K, and P. All there. All right. So let's look at some questions here. Answer each question. When using Google Sheet, please write the function key was used and the numbers are input. Okay. Hussein wants to buy a car. gaming computer for $3,500. Wow, that's an expensive computer. He wants to finance the entire amount. Okay. Store offers 2-year loan. The interest rate is 8.5 compounded monthly. Okay, it says compounded, so it's automatically amortized then, right? So if he takes this loan, what will be his monthly payment? So let's identify what all these numbers are given to us. So first of all, is borrowing $3,500, so that's my principal balance. It says it's 2-year loan, so that's T. Time is 2 years. Again, interest rate is 8.5%, so R is 0.085, R for interest rate. And it's monthly, so that's my K is 12. Again, you notice that it's monthly payment and compounded monthly, they have to always match 12 times a year. That's why K is going to be 12. So let's kind of scroll down. So the formula was that. So I'm using this, I'm going to input that into Google Sheet. So I'll do equals PMT. Interest rate is 0.085 over 12. So that's first part. It says to input R over K. Interest rate over the monthly. So that gives you like a monthly rate per se, comma. The next one is total number of payments. So it's 2 years, so 12 times 2, because I'm making 12 payments for 2 years. And then the last one is the loan amount. So this. Okay. When you input all these numbers, you're going to get negative 159.09. Again, it gives you negative numbers, so because they think you're making payments, so it's negative. So what we do is you can actually put negative sign here, then it'll just come out the positive. So, or you can just ignore the negative and say it's 159.09. So my monthly payment is going to be $159.09. Okay. So I put extra negative there. Maybe I should put extra negative PMT R over T, K times T, and then P. Okay. Let's look at the second question here. How much interest is he paying for this loan? Again, there's no formula. Basically, interest is like, again, when you borrow money, you ended up paying more than what you borrow. So here, I'm going to calculate total payment. So he's paying $159.09 per month for 2 years, right? So let's talk about how much he's paying total. So 159.09 times 12 times 2, because he's making 12 payments a year. He's doing it for 2 years. So this is total that he's going to pay back. So when you calculate this out, I get 3818.16, right? So what does that mean? He borrowed 3,500. He ended up paying 3,800 and some, right? So how much interest is he paying? Well, that's the difference between those two. So 3818.16 minus 3500. Again, he borrowed this much. He ended up paying for this. So he basically paid like $300 more because of interest. So 318.16. So that's my final answer for that question. All right, let's look at the next one. If the loan was a simple interest loan, how much would you pay for back? Again, for simple interest, we have to use this formula. Simple interest is P1 plus RT, right? So that means future value is, principal is 3,500. That's how much he's going to borrow. 1 plus interest rate is 0.085. Time is 2 years. Calculate that out. I get 4095. Oh, that's so. If this was simple interest loan, he would have to pay back, because the future value of that is 4095. So that means he has to pay back $4,095. When it was amortized loan, he ended up paying back $3,800. So obviously, for a simple interest loan, you have to pay back more, as I mentioned before, because they'll charge you interest on very first amount throughout the whole loan period. Okay, so that's how much he has to pay back versus that, which is better, right? Well, I mean, this is better than that if I have to pay back, right? If I have a choice of paying 3,800 versus 4,000 something, I'll choose 3,800, right? Okay, let's look at the last one. his monthly payment be if the loan one has a simple interest. So monthly payment will be, so he has to pay back this 4095. They're going to be total payment of 24 payments because it's 2 years. So 4095 divided by 24. It's going to be 170.63. I round off. So he has to make $170 payment. Instead of, with the amortized loan, it was almost 160. So again, simple interest loan is a little bit more expensive than amortized loan. All right, I'm gonna have you try number 4 and number 5, and I think we're done.